All right, let's get started here. First and foremost, welcome to Autodesk Virtual Academy, brought to you all by your friends here at KETIV Technologies. My name is Nigel Mbayak, one of the customer success managers here on the KETIV team. And today I'm joined by my good friend, Cameron Wetton. Cam, how's it going?
Going great, Nigel.
Great to hear, Cam. And if you didn't already know, Cam's been on AVA a number of times, dabbling a lot in the Inventor and automation for Inventor space. He's one of our AEs here at KETIV, working on our services delivery team, working on plenty of automation projects for our customers. I'm sure Cameron will talk a little bit about that moving forward. So today we're going to be going over enhancing iLogic with Windows Forms. So just another automation webinar. It's been like the really hot topic over the last, I would say 12 to 18 months. We get a ton of requests for it. So, we'll deliver on those requests. If anyone has any questions at any time during the webinar, go ahead and type those into your respective chat or questions panels, and we'll go ahead and address those. But Cameron, before we get started, do you have anything else to add?
Nope, that's great.
Cool. I'll let you take it away. And what I'm going to have our marketing people do right now is go ahead and post a link to a survey that you can go ahead and open up right now or at the end of the webinar to go ahead and just answer a couple of questions for us. So you'll see that in the chat panel shortly. Go ahead and fill those out. That helps us determine what sessions we do in the future. But without further ado, Cameron, go ahead and take it away.
All right, thanks, Nigel. So today we're going to be talking about enhancing iLogic with Windows Forms. Now, as many of you know, and maybe some of you don't, iLogic is a powerful tool for automating your Inventor designs. And iLogic Forms are great for creating a user interface for your automation. And most of what you will need can be done with the built-in form functionality inside of Inventor, but sometimes you need something more advanced. So today we're going to cover what to do when you need more advanced user input. So we are going to cover, we're going to learn how to set up an iLogic rule to interact with a custom Windows form. And specifically, we're going to make sure we cover how to display a custom Windows form to the user, how to send data to the form from an iLogic rule, and how to receive user inputs back from the form so that you can use them for other things inside of your iLogic rule. And to do this, we're going to go over an example of a custom form that I've made and a rule that uses that form. So let's go ahead and switch over to Inventor. And I've got an assembly here. A simple assembly, doesn't have much to it. It's got a couple of brackets. These are the same part. There's just two occurrences of it in this assembly. And then this other little part that's floating out here. And inside of this assembly, I've got just a handful of user parameters. Most of them are numeric type, and then one text parameter. And what we're trying to accomplish with this assembly is like Nigel said, I'm working on the automation team here at KETIV, and we work on a lot of projects for our customers to build automated assemblies. So there's some kind of a form or input where the user can, specify the parameters or the properties, the inputs for that assembly. And then we've got code that actually creates the assembly automatically according to what the user has specified. And a lot of times that involves having an assembly with lots of parameters in it. And then those parameter values need to get passed down into different components inside of the assembly so that those components can resize and reposition themselves according to the user input. And so the way we set that up is a lot of times we'll have our assembly that has a whole bunch of user parameters in it. And then we'll have to go down into our part files and make sure that those same parameters are set up in those part files so that when the assembly passes those values down, the part files are ready to receive those values and then adjust themselves, work with those values. And most of the time we have to create the parameters in the assembly. And then if I want these same parameters in a part file, then I have to go down into the part file, open it up, and then maybe I take a screenshot of my parameters in my assembly, go down into a part, open up the parameters, and then manually start typing, okay, I need to a numeric parameter named length Z, and then add a numeric parameter length X, etc. And I have to create these one by one. And you can imagine if there's a lot of parameters, then and a lot of components that need those parameters, that can take a lot of time. And so I thought in order to speed that process up for myself, what I would do is I would create an iLogic rule that would essentially do that for me. I'd create the parameters manually at the top level, and then I would have my iLogic rule would copy those parameters down from the top level assembly into the subcomponents. And so I did that, and it ended up saving me tons of time. And there were a couple limitations with it. For one, it just mostly just copied every parameter that I had, user parameter that I had in my assembly, copied it down to a single component that I've selected. And that wasn't always something I needed. Sometimes I didn't want to copy all the parameters. Sometimes I want to just choose specific ones that need to go down to a specific component. And there were also times where I needed to maybe copy it to multiple components at the same time. And so, so the next thought I had was, okay, that's going to require some user input. I have to tell the program, these are the parameters that I want to copy, and these are the components I want to copy it to. And so I needed some user input at that point. So my thought was, I've got my rule that copies the parameters. I'm going to need a form for input to choose the different parameters and components. And so, okay, first thought occurred to me was let's just create an iLogic form using the built-in functionality. And I've been able to do a lot with this stuff. You can create some pretty good user input forms for inputting parameters and all sorts of stuff and properties with the built-in iLogic form functionality. But what I really wanted was to be able to have the form to have a list of all the parameters and a list of all the components with checkboxes that I could choose for each one. And there's not a way to do that inside of an iLogic form. There's just no control that'll handle that sort of input. So that was when I realized, okay, I've got to go outside iLogic and build a custom Windows form to be able to do that. And so that's what I did. And I've got this copy parameters rule. I'll go ahead and run it, and so you can see the custom form that I created. It essentially, the iLogic rule goes through, gets a list of all the components in the assembly, and a list of all the parameters in the assembly, well, the user parameters in the assembly, and then just writes them out into these two different lists. And now I've got checkboxes that I can use to choose which ones I want to copy and which components those will get copied into. And I've also added some functionality where I can uncheck and recheck all, and then I can choose to copy the parameters from there. And I've also got some, some icons here to indicate whether it's a part or an assembly, and then also some icons here to represent the different parameter types. These orange ones are numeric, the gray ones text, and then I've got another one for a true/false parameter, which I'll show you in a minute. So the idea is here, I need this user input, but I couldn't do this through iLogic forms. I had to do this through a Windows form. So let me go ahead and show you an example. If I add a true/false, and go back and run that again, it's going to go through, collect the user parameters. Now it sees that there's a new one, and it's a true/false, so it's got a different color. So this is what I wanted to do. And today we're going to go over how I accomplished that. So what I used to build this form is Microsoft Visual Studio, and because that's what I use in my day-to-day work. But so you can use Visual Studio or any other developer environment that lets you build Windows forms, and as long as it has the functionality that you need, and as long as it compiles the form into a DLL, that's really all you need to be able to make this work. So I'm going to go ahead and switch over to Visual Studio, and we'll talk about the form. Now, we don't have enough time today to go over a tutorial of how to build a form in Visual Studio. But there are lots of resources out there on the internet for lots of tutorials for building Windows forms. So go ahead and check that out. There's even on the Autodesk website, the Inventor customization forum is a great place to learn how to do all this kind of stuff. In fact, I think one of their pinned posts, one of their sticky posts is how to build your first plugin, and it goes over building a simple form and how to plug it into Inventor. So that's a great resource for learning how to build a custom Windows form. So what we'll highlight today is just the high points and the important points to set up inside of your form so that you can make sure that it's ready to plug into iLogic. Okay. So the idea here is you start your solution in at least in Visual Studio, you start your solution and create a project for your code, and then you want to add a Windows form. So you either right click on your project and go to add new item, and then it'll pull up a list of different items you can add, and one of the ones will be a Windows form, or you can just pick it directly off of here. So here, form, Windows forms. So you add that to your project. It'll ask you to give it a name, and that'll be important. You want to choose a name that makes sense and that you can remember for later, because that's going to show up in how we link this up through iLogic. We'll be making use of what the name that you give it. So we'll talk about that more later. So you create your form, and that's going to come up with just a blank form that doesn't have anything in it. You'll want to add your controls to it by going to your toolbox, picking the things you want and dragging them over. So if you want some buttons, you just click the button, drag it over, drag another one over. If you need labels, that's this text here. It's called a label, bring it over. This box here that I'm using to list items and have check marks next to them is called a list view. So I pulled that over, and then here's a checkbox. You pull that over. Once you've got your control, excuse me. Once you've got your controls placed, then you need to configure them by just selecting your controls and going to your properties. There's lots of different choices you have here to set up how this control behaves and what it looks like. So the text is going to be what the button shows, right? And then the name is an important thing here. We'll want to, the controls that we're going to be interacting with in our code later, we'll want to give those a name. And so, yeah, so you get all that set up the way you want. And then what you want to do, once you've got your form set up, you have to be able to tell the form how to behave. So you've got to be able to write some code to tell it what to do. So for example, this functionality over here, where I run this and I hit this checkbox, when I mark this, then it marks all these. Like, it doesn't automatically do that. I have to write the code to tell it to do that. And so there's going to be some code behind the scenes of this form of telling it what to do. And to see that, you go to your Solution Explorer and you expand that form. And right here is going to be the class code that's behind that. So I've selected that. And here's the class. And the class name gets that name from whatever you named the form. And that's what's going to be important later when we link this up to iLogic. But here's basically just a list of properties and methods that control how the form behaves. And I'm not going to go through most of this, but the important parts are going to be this section here is what happens when the form actually gets loaded for the first time. If we want it to run specific bits of code, that's where we put that code. And so, for example, what we want to do when that form loads, we want it to be able to build the list of components and parameters. We want it to fill this list out to present it to the user. And we want that to happen on load. So that's where we place the code to do that. And then, of course, when we hit the button to either cancel or to proceed with the copy, then we have to write the code to tell the form what to do when the user does that. So this little section here is when the copy parameters button is clicked. And you'll see this is where the naming the controls becomes important. So this control here, name is called button copy parameters. So I know what this function does. If we just stick with the default names, it'll just say button 1 click and button 2 click, and it can be confusing what exactly those are. So that's why it's important to give them a good name. So you go over to properties, name, there it is right there, button copy parameters. So that's what happens when we click that button, it's going to run this code. And so we'll talk about these two here in more detail. The rest of the stuff, there's a cancel button. That's important. When they hit cancel, we want it to close. And this dialog result is going to be important later when we link up to iLogic. We want to be able, once the users input some data into their form and click the button, either cancel or copy parameters button, we need to know in iLogic, the iLogic rule needs to know which button the user picked. And so we're using this dialog result property to keep track of that. So we do make sure when they click the cancel button that we set this dialog result to cancel and then close it out. Or if they hit the copy parameters button, then we need to know they hit that instead. So we set the dialog result to OK and then close it out. And then I'll show you later how we link that up in the iLogic rule. Okay, so let's go into a little more detail of what's happening here in order to actually get this form to work. We've got these 4 properties that we've defined up here inside of this class. These 2 properties here are lists of the component, list of components and a list of parameters that are going to be inputs to the form, which basically iLogic builds the list of components in the assembly and the list of parameters in the assembly, and then it passes those lists over to the form, and the form stores them in these properties. And these are a list of object. And so that's how we get the initial list to display to the user. And on the form load, what we do is we have the code go through, okay, for every item in this list, it's going to loop through and do some code. And each item in that list it's a string array. And I've set that up so that we can actually pass 2 values over. We want the component name and the component type, whether it's a part or an assembly. And I'm passing those over as a single line item in this list. And I do that by building a string array with those 2 values. So the first element of the array, index 0, is going to be the component name. The second element of the array is the component type. And okay, so now that we've extracted the values from the array, then we need to actually build the list item, the item that actually is going to show up in this list right here. So we define that as a list view item. We add it to the list and we give it the component name. That's the text that's actually going to show up in the list. And then we need to set the icon type based off of the component type itself. So we just select, okay, if it's an assembly, then we use I'm using an image index here to keep track of my different icons, and I can easily select which icon to use for this particular list view item. And I don't really have time to go into that, but if you want some more information about that, you can just Google this image index, and an image list on the form is how I'm taking care of that. So based on which type it is, I choose which icon to use, and then that's it. And I loop through each item in the list that got passed over from iLogic, and that builds our component list. Then we do the same here for the parameters list. We again, the parameters are being passed over as a string array because I want to keep track of the parameter name and also the parameter type, whether it's numeric, text, or true false. And so the first element of the array is the parameter name, so I extract that. Second element of the array is the parameter type, so we extract that. Build the list to view item just like before, and except this is in the list view for parameters instead of the list view for components. And that's the name of this control right here, this list view control and that list view control. So I'm adding to this parameters list view, and I'm giving it the parameter name, so that'll be the text that shows up. And then I want to choose the icon based off of the parameter type, whether it's numeric, text, or Boolean. It chooses which is the correct icon to display for that. So that's what happens on form load. It basically just builds a list in order to display the information to the user. And then once the user goes through and makes their picks, they check which parameters they want, check which components they want. Then they either hit cancel, close everything out, or they hit copy parameters. And when that happens, we need some specific things to happen as well. So we write some code here. What we want to do is take the selections that the user made and pass those selections back to iLogic so that we can do further things with them, actually do the copy of the parameters. So that's what this little bit of code here, it collects those lists of the user that the user selected for. So there's our list view components, and we go through all the checked items. And for each checked item that the users selected, we add it to this component names list. And we just add the text, which is going to be the name of the component that they selected. So this component names list is a separate list that we've created up here. So we've got these 2 properties for the input lists and these 2 properties for the output lists. So, and these are just a list of string because we're just passing back component names and parameter names. So we set those up here, and this will be important for linking the data back into iLogic, and I'll show you late in a bit how all that works. But essentially, these are the lists we want to build to output the user selections. And so that's what this does. It just loops through each of the checked items, adds each checked component to the list, adds each checked parameter to the parameter names list, and then we're done. So we say the user hit the OK button, and then we close out the form. And then that's essentially it. This other code down here is for, controlling the, when you hit the check all button like here, then it checks all the boxes and stuff like that. And then I've got also some sorting for clicking on the column headers, and then just some controlling how the different controls are resized, but we don't really need to go into that. It's tangential to what we're talking about today. So, all right, so that's our form. That's how we set it up. One other thing that's important is we need to actually compile this code into a DLL file that we can reference from iLogic. And that's the important thing. You want to compile it as a DLL. So you want to make sure when you set up your project, let's go take a look at a couple of important properties you want to set up in your project in order for this to work correctly. So I right click on my project, hit properties. One important thing is that is going to come up when we link this to iLogic is this root namespace. So you'll either want to change that to something that makes sense to you, or just make note of what it starts out as. We'll be referencing that in a moment when we link it up to iLogic. We also want to set this up as a class library. That's what tells this Visual Studio to compile this as a DLL. And then we want to take a look at the compile tab and see what our output path is. So when we actually do this build and it creates a DLL, where is that file going to end up? We'll want to make note of that. And so here it's going to be in my actual visual, the same folder that my actual project and solution are in, and then a subfolder bin and debug, and then it'll be in there when I build it. Okay, so now that we've got all that, then we'll go ahead and go up to build and hit build solution. That's going to create the DLL. I'm not going to do it now because I've already got Inventor open, and Inventor's already looking at that DLL. So if I try to build it, it'll just say, hey, I can't do this. It's already in use by another program. So when you do it, you want to make sure you have Inventor closed, and then you hit build solution. And then that's going to compile. So if we go and take a look at, here's the folder that has my solution in it, my Visual Studio solution. Underneath there is my Visual Studio project, copy parameters. And then inside of there is going to be, this is also where I keep the icon images that I use. And then underneath that's the bin folder. There's that debug. And then there's the file that gets created, copy parameters. It's going to have the same name as this file right here. This copy parameters. Oh no, it doesn't have the same name. It follows the class. Follows the class name. No, it doesn't. Copy must be the project. Anyway, that's the one we want to look at. Copy parameters.dll. Might actually be the namespace. Okay, so once we built it, now we're ready to link it up into our iLogic rule. So let's go take a look at that. I'll switch back over to Inventor. And here's my rule. Now this is a simplified version of the real thing. There's a lot more that goes into setting up a rule like this and making sure that it works correctly. But I've basically boiled it down to the important points for what we're covering today of linking in an external custom Windows form. So the basic idea is here we've got this section here, which actually builds the list of components that are in the assembly. And it also goes through and makes sure, because there's actually 2 bracket components, we don't want that to show up twice in the list that's presented to the user because they're the same file. They're just 2 occurrences of the same thing. And so we just have a little bit here that set this up so that it only, if it's already been placed in the list, it doesn't place it again. So it just basically returns a list of unique components. So that's what this section does. We'll talk about that in more detail. And then this section here is what builds the list of user parameters in the assembly. And then once we've got both of those lists, we're ready to use the custom form. So we set up a couple parameters here, or a couple variables. And then this block here is kind of the star of the show. This is where we're actually loading up the dialog, sending it the two lists that we've compiled, waiting for user input. And then once the user is finished with the form, it sends the lists of selected values back. And then we go on and do stuff. In this case, we would actually perform the copying the parameters from the assembly down to the subcomponents. But that's a huge chunk of code that we definitely don't have time to go over. So I've basically just, it's not really doing anything except I've added some simple reporting here where it just builds a text string that shows us these are the components the user selected and these are the parameters that the user selected, so that we can actually see what values we're getting back when we run this in a minute. So, all right, so let's go to a little more detail of what's going on here. So the most important thing is going to be this add reference at the top. This line of code lets Inventor know where it can find the form that we compiled, our external form that we created. So this is going to be a full path reference to that DLL file we created. So here you can see the path. We've got this add reference keyword. That's a Visual Basic keyword that lets it know we're adding a DLL in. We've got our full path. So there's the path for my Visual Studio project. There's that bin/debug. And then this is our DLL that we compiled. Okay, so once it's got this reference to the DLL, it knows how to find that form, and it can find all of the classes and properties that we've set up in that form. And this add reference line of code goes at the very top of your rule. You can see it's actually in this separate header section. So if I can toggle that header on and off, that's where that add reference will go. Basically needs to be at the top. Most recent versions of Inventor have this separate header section. If you have an older version of Inventor that doesn't have a header, you just need to make sure that this is at the top of your rule. You can add comments above this. That's fine, but otherwise this needs to be at the very top of your rule. Okay, so now that we've set up our reference, then let's take a look at how we're compiling that list real quick. First of all, we just dim up the components list as a list of object, because again, we're putting the list items that we're putting in there are going to be string arrays. And so we need to, it's just listing, it's looping through all of the occurrences in this assembly. It's grabbing the component name and then doing this check to make sure we just add unique ones and not duplicates. And then down here, we're grabbing the component type, and we're actually adding to that components list, we're dimming up a new string array that has the component name as the first element, and then the component type is the second element. So if I switch back to Visual Studio here, you can see that's what's going into this components list here. And we've set it up so the first element is the component name, the second element of the array is the component type, and this assembly and part values are what I'm reading. So that needs to match exactly what I'm setting up right here, assembly and part. So I detect what type it is just by looking at the part or the component document, and based on that, I set whether it's assembly or part. Set that string over, build that list to the whole list of components in the assembly. And then the next thing is to build the list of user parameters. So same idea, so I set up this parameters list as a list of object. I loop through all of the user parameters in the assembly and grab the parameter name. And then depending on what the units type are, whether it's text or Boolean, then I can grab the units into the parameter type, or if it's neither of those, then it's numeric. So I just put that into the parameter type. And then again, I'm building a string array where the first element is the parameter name, second element is the parameter type. And then again, that corresponds to what we've set up over here in our rule here. First element of the array is the name, second is the type, and then the type, this numeric, text, and Boolean, when I go to check the type, those need to match up with what I'm sending over here, text, Boolean, or numeric. Okay, so that builds up our parameters list. Now we've got both of those lists. We're ready to launch the dialog. We're going to create a variable, a Boolean variable to let us know if the user actually clicked the OK button, which on the dialog is that we named it copy parameters, but that's essentially the OK button, letting us know that we're good to proceed with the rest of the rule. And I'll show you how we use that. And then we've also dimming up a couple of new variables, lists of strings, and these are going to be the variables that are going to hold the data that comes back from the form, right? After the user checks the boxes for which ones they want, the form is going to compile those into two separate lists of components and parameters and send those lists back to the iLogic rule and store them in these parameters here, or these variables here, so that we need to set those up ahead of time. And now we've got those set up, then we're going to actually load up the form. And we're going to use this using block, which is a good way to interact with the form. And the way that works is you essentially dim up a new object. We're calling it input form, and we're dimming it as this is the type of object right here. And how you know what to put here is going to be, this is going to be the namespace of what you're trying to get inside of this, from this reference DLL. And that's what comes from over here in our project properties, this namespace right there. So if you're not sure what to put there, come over to your your project, look at what the namespace is, and that's what you're going to put right here. And once you specify the namespace, then you do dot, and then we have to specify the actual class that we want to access. In this case, copy parameters form. And again, that's going to come from over here in our form code. That's going to be this name of this class right there. So if you're not sure what to put there, come here and look at what the class is called, and that's what we're going to put here. Okay, so namespace.class. That's the type of object we're creating. So that lets Inventor know we are dimming up a class, an object that represents that form, an instance of that form. Okay, so now that we've got that initialized, then we have to send before we actually load up the form, we have to send it the input values, the input lists. So that's what's happening here. So we've got our components list. That's the list that we created up here. We dimmed up this components list, looped through and built a list of all the components in the assembly. We are right here, we are sending that into the input form, and then we're accessing the property on that form that we've named components list. So if I go over to Visual Studio, that's what we named this property right here, right? So this is the property we set up to take the incoming list, to take the input from iLogic. So if you're not sure what to put there, we want to look at what the property we've named, components list. So it's input form dot components list. And then we're going to set it equal to the components list that we built up here. I maybe should have named these slightly differently so you could tell like this is not the same object as this. They're two separate objects, but we are setting them equal right here. So that essentially sends those component lists and parameter lists to the form. The other thing we want to do is we want to make a link to the output lists so that when the form gives us the output, we have access to it. And so that's what this next section is doing here. Very similar to the first, we're just linking up the parameter on the form called component names, or excuse me, the property on the form called component names. So that right there. So component names and parameter names, those are the two properties we set up here to act as the bin that the output is going to end up in. So we set that equal to this variable that we set up right here. So when the form takes the user input, builds that list, it's going to end up stored in that variable right there. Same with the parameter names right there. We write that to that property, or we make them equal. So we're basically sending a reference to that variable to the form so we can fill it out. And then when it fills it out, it automatically fills out this reference variable here. Okay, so we've sent it all the objects we need to send it to get started. Now we actually want to show that have the form pop up and prompt the user for input. So that's what this line of code is doing. We're taking our input form and we're running the show dialog method that actually causes that form to pop up. And when that happens, you'll see it says function form.show dialog as dialog result. So what we get back when we run that function is a dialog result, which is a special kind of object that Visual Basic uses to let us know. Essentially, we're using it to let us know which button the user picked, right? And it comes back as an enum, which is just a type of constant. and it can have different values. So we dim up this special form result as a dialog result enum so that we can get that information back from this function when we run the form and the user finishes running it, it's going to send us back this result. But that comes back as an enum where our dialog results appear. We've dimmed it as a Boolean. We just want to know if it was okay or not. So this little statement right here is going to just convert that enum into a Boolean. So basically, if the form result comes back as VB okay, that's one of the options you can use as one of the values that dialog result can come back as. If it's comes back as VB okay, then we just set our dialog result to true. Otherwise, it just stays false. So that lets us know if the user hit the OK button or the copy parameters button, then it'll set this dialog result to true. So then we know after we leave this using function, what's going to happen is, the user has put their input into the form. They've hit one of the buttons. Once that's done, it's going to end this using function. It's going to discard this object. So the form closes and we lose the object and any reference to any of the properties and values that it had stored in it. And so we need to be able, there's several things we need to get out of that we don't want to lose after it gets discarded. And so one of those is what happened. Did the user click OK or cancel? That's why we have this. That's why we define this variable here, so we could know outside of this using block what's happened. And that's also why we dimension these component names list and parameter names list outside of that using block as well. So once this using block is finished and this object gets discarded, we still have access to the values that were stored there. Okay. Hopefully that makes sense. It's kind of abstract, and I'm doing my best to communicate exactly how this works, but we'll get to some questions at the end in case any of this was not clear. Okay, so at this point, when we run the show dialog line of code, the iLogic rule is going to pause at this point. It's going to pop up the form and wait for the user to finish doing their input on the form, and it won't resume until that form gets closed, either by them hitting the OK button or the copy parameters button, or they hit the cancel button, or they hit the X in the upper right corner. Any of those options is going to close the dialog and give us a result to let us know what happened. Only at that point will this code, the iLogic rule itself, resume from this point. So, all right, so once we've gone and got the user input, and the user has closed the form, then we check, okay, if the dialog result was not okay, if this is not true, then basically that tells us the user canceled the process. They don't want to continue with the copy operation, so we just bail out. We exit our iLogic rule here and don't continue. Otherwise, if it was true, then it continues on, and we would actually have a lot of code here that actually does the copy parameter part. But here, like I said, we've just got some message text that lets us know what input we got back from the form. So let's take a look at that. We're going to go ahead and run it and see what we get back. So let's go ahead and select both of our components here. Check a handful of these parameters, and then let's hit copy. And this is that just compiled message box code that's at the end of the rule. Lets us know, okay, these are the options that were selected from the form. And if we want to do, let's just maybe do one of these and then just a couple of those. Hit copy. Okay, so this lets us know we're actually getting the right user input back from our external form back into our iLogic rule, so we can continue to do real stuff with it. Okay, so I think that's all I had there. Let me just switch over and talk a little bit about some of the recent solutions that I have personally been working on here on the automation team at KETIV. Is many of the projects I've recently been working on involve creating a custom form like what we've been seeing here, either something as simple as what we saw there, or it can be quite a bit more complex. I mean, the sky's kind of the limit with what you can build with Windows Forms. And we take the user input from those forms and we write a whole bunch of code in the background that says what to do with that input to convert it into an actual model inside of Inventor. And we can do anything from simplified sales models up to fully detailed manufacturing models and anything in between. Also, another recent project that I've been working on that was really interesting is building custom bills of materials where we've got various sources of information. Either we've got Inventor models that have data inside of them. We've got Excel documents, even output from AutoCAD. We can take data from all those various different sources and compile them into a custom bill of materials that is laid out in a very specific way that you might, maybe have a specific set of information that you want to send off to your customer to explain, what they're getting with their order. Or you might need to send off a purchasing list to your purchasing department, let them know what to buy for this project so that you can build your model. And then along those same lines, I've also been recently working on a project that's really interesting where we are automating some project documents in Word. Like, for example, a submittal document or a proposal document to your customer. We've got all this information inside of our Inventor models when we build them. It's almost a shame when we go to actually document some of that stuff that we just have to manually type out all the same information that's already stored in our Inventor model. And so we've developed a solution where we can extract the data from the model, export it, and then export it from Inventor and use that information to drive an automated proposal document. Yes, there's a lot of exciting applications there. So I just wanted to bring that up to let you know some of KETIV's capabilities. If any of this stuff sounds exciting to you, if it's something you're interested in, please reach out to us. Let us know. We can definitely build solutions for you, or we can even help you if you're adventurous and want to try and take some of this stuff on yourself. We also offer training and mentoring on how to do this stuff. So, all right, Nigel, should we get to some questions?
Yeah, let's just hop straight into questions. First and foremost, too, before we jump into those questions, Jessica just dropped a link into the chat as well with a really awesome automation starter kit. Essentially, it's our automation DIY kit that Jess brought up in the chat. So go ahead and click that link. Essentially, you fill out the form, and then you get some really cool documentation back to help you get started with this process. I know it is sometimes a very overwhelming undertaking to start automating stuff. It's just completely different, right?
It is. I mean, there's so much you can do. There's so much power here, but there's so much to learn. And I would recommend, if you're going to do something like what we showed today, if you want to build an external form and bring it into iLogic, I would say if you've never done anything like that before, start simple. Like, just start with the most basic form with just one or two inputs that you can drive and make sure you're understanding the process of linking up an iLogic form to.
Exactly. And that's the cool thing with automation is you don't have to automate the entire process, and it doesn't all have to happen at once.
Yeah.
You could automate, say, for example, you wanted to write certain parameters to your models and you wanted that to automatically happen based on certain inputs. You could start your templates out with a form, right? And then just have that write out whatever parameters you wanted for this particular model. And boom, you've already taken care of some of the manual effort that a user would have to do on the back end. And you just, you keep doing that over and over again. 5%, 5%, 5%. And ultimately you get to a point where like, hey, I've got 70% of my process automated. But I did it in small chunks.
Yep, that's the right way to start.
Yep. So let's go ahead and jump into some of these questions. So first is from Henrik. Is it possible to use VBA and not use Visual Studio?
I don't know if VBA has a form.
I'm not sure. I've only seen it with Visual Studio. That's my experience.
Yeah, I don't have a lot of experience with VBA other than just scripting in it. But as far as like building a form, I mean, I suppose if you have access to the API to build a form, I don't know. It doesn't have like a toolbox to help you easily create forms. If you were trying to do that all through code, I wouldn't even try that unless I'm just not aware. Maybe it does have something like that, but
maybe it does. I've only ever seen it using the method that you have. So
yeah.
Another question from Jared. Will this be available to review after the webinar ends? Yes, it'll probably take about a week for this to hop on our YouTube channel. So that's youtube.com/KETIV Technologies. You can go ahead and review it there. Alternatively, you could reach out to anyone here at KETIV if you need it ASAP, and we might be able to get you the recording earlier.
Yeah, I went through a lot of that code really quickly because I wanted to just highlight the the most important points
The
for
concept.
linking up the external form. But yeah, if you want to go back to it, once this is posted to YouTube, you can go back to the video and then maybe just pause and look at a little more detail of exactly all the code that's there.
Yep. Question from Jeff. Is the .NET version important when building custom forms for Inventor? I believe it is.
It is. I mean, you do want to make sure that you're using a version of .NET that's compatible with Inventor. Inventor is usually pretty good about staying up to date with recent versions of .NET. If you're in doubt, you can check the Autodesk website. They've got some knowledge network articles on what versions of .NET are compatible with which versions of Inventor. I mean, if all else fails, you could use an older version. Like you maybe have seen when I was pulling up the properties for my project that I was using .NET 4.5, which is several versions back. It doesn't hurt to do that as long as that version of .NET has the functionality you need. Then it's safe to maybe use a slightly older version just for compatibility's sake.
100%. Another question: is it possible to get the code? So this is a question we get every time we do a webinar. Some stuff we can share, some stuff we can't. So your best bet would be to go ahead and reach out to either your account representative here at KETIV or someone on the marketing team here at KETIV, and ask for what you need, and we'll see what we can get you. Is there an explicit function in the form that sends the output from the form back into the iLogic rule, or does the form write the output values back to the iLogic rule automatically because it is a quote-unquote shared object?
Yeah, there is not an explicit function to do that. I mean, the Windows form inside of Visual Studio basically has no idea that the iLogic rule exists. It doesn't know what's running it. So there's no explicit function to send the values back. Essentially what we're doing is we're using a variable. We're sending it, if you're familiar with like sending variables and functions inside of code, you can either send them by value or by reference. We're essentially sending the list variable by reference so that when the form code writes values into that variable, it's essentially that variable is shared. It's available to both the custom form code and the iLogic rule code. And so when the form writes to it, the iLogic rule can see those same results. So that's how we're getting that to work. That's how we're getting those values back.
Cool. Let's jump into the next one. Do I need Visual Studio 2017 installed when using Inventor 2021, or can I use Visual Studio 2019?
2019 works just fine. That's what I'm using. And I use 2019 for Inventor 2019, 2020, 21. I've even used it for AutoCAD 2017. So there's usually not a compatibility issue there. But if you're skeptical about that, or you want to be sure, I think there is, again, some knowledge network articles on Autodesk about, or maybe even search the customization forums on Autodesk to see if there's any compatibility issues with different versions of Visual Studio. I mean, as long as you're using the right interop assemblies and the right version of .NET, a compatible version of .NET, then you shouldn't run into any issues.
Yep. And then Daniel Ramirez got a great question here. What do you recommend on how to divide an automation project for a simple design? So I guess determining how to split up your project if you don't want to take it all in one big chunk, which I think is the best way to do it.
That's a good question.
I think you have to look at it this way: is you have to look at what you're trying to accomplish and see if there's ways where you can break it down that makes sense. For example, if you're doing some sort of big industrial machinery, what I've seen before is these things like on skids, for example, these skid-based designs. People will automate like the skid creation first, and then they'll still do their like manual modeling of whatever goes on that skid, to get to the point where ultimately they're going to add that portion as well. So if you can break your model down into a couple of pieces, and start the automation on a few of those pieces and still manually do the rest of it, with the intention of ultimately automating all of it, that's one way of doing it. Also, I wouldn't suggest doing the drawing automation first. By no means.
Yeah.
That's
Yeah,
like
drawing
probably the
automation
most
is quite a
complex
beast.
part.
Yeah, I would
So,
save that for the end for sure.
yep,
There's a lot
100%.
that goes into that, and it's easy to take trying automation too far. Like there's a lot
Yeah,
you
I
can
think
do with it, but at some point you hit the point of diminishing returns where you're putting a lot of
I
code
was
in, doing automating
literally
stuff.
going to say the same word, diminishing
Yeah,
returns. You're going to put a ton of effort in. It's really not going to save you that much time on the back end. Or
yeah.
maybe it's
So
going to be more time in the front end than you save on the back end.
yeah, I mean
So,
it's definitely worth doing some automation in your drawings, but you have to be wary of the point of taking it too far.
yeah, like every annotation, every bubble, every balloon. Um, yeah, just be careful. The good thing is you have all of this freedom. The bad thing is you have all of this freedom. So it's just one of
Yeah,
those things.
exactly.
But Daniel, if you want any, you know, if you want our opinions on that with your particular models or your assemblies or whatever you're building, go ahead and reach out to somebody here on the team, and we'll see if we can get like a little conversation going with one of our automation architects and see if you know, we can help you build a game plan for that. Can you do the same, I guess, like the same concept that you did today, if the form is in an add-in?
I mean, yeah, you can definitely pull a form into an add-in. We do that all the time. I would say that's probably the most common workflow that we use when in our automation projects. But there's not really, if you're using an add-in, you maybe don't necessarily need to have iLogic involved in
Yeah,
actually launching the form. So, but I mean, even if you do have iLogic, you can do exactly what we did if you're doing stuff with an add-in. Although I guess as long as you've got access to that DLL, which would be compiled as part of your add-in, then yeah, you can still do the same thing. You just might, if you're doing an add-in anyway, you might just take a different approach anyway.
right. And then this question is a two-parter. Do you have content in the Spanish language, and do you have any content on Forge? We don't actually publish any content in Spanish, but we do have multiple instructors on our team that are fluent Spanish speakers. So we do offer training and mentoring in Spanish if that's something that you require. In terms of Forge, it's really hard to do content on something that's so, I guess, freedom enabling. You can do so much in Forge. It's really hard to like narrow it down to one thing. Uh, so that would be one of those things. But yeah, if you have any questions about Spanish language information, reach out to somebody here on the team, and we'll see what we can do for you. All right. Can you do basic forms in VBA? I mean, you can make them as basic as you really want to, right?
Oh, that was a similar question to one that was asked earlier. I'm not familiar with any form capabilities inside of VBA.
That's one of those things where I need to talk to EP. I'm pretty sure
Yeah.
it's if they have it, I wouldn't be surprised if it was more limited than what's in Visual Studio, and I would just run everything through Visual Studio, honestly. Once you get used to the interface and stuff, just do everything in there, right? Don't have to bring in another thing, especially if you plan on like adding more stuff later in terms of like automation capabilities. Almost all of it's going to get done in Visual Studio anyway, so you might as well start there.
Yeah, I mean, if VBA has the ability to create forms, then I would say, yeah, you can absolutely do what we just did here. You just need to, if you need to link it up to iLogic, you're going to have that DLL. So if VBA can export that DLL for you, can compile that code as a DLL, then iLogic can get access to it.
And then Luis Sanchez, can you use forms to modify parts and assemblies directly? Absolutely.
Can you say that again?
Yeah, can you use forms to modify parts and assemblies directly? I mean, if you set it up that way, I don't see why not.
Yeah, I mean, with code, yeah, you'd have to write the code to tell it to do that. But I mean, that's the kind of stuff we do
regularly.
Yeah.
So yeah, the answer to that is yes. And all you have to have is like the intelligence behind the code to understand what changes based on the inputs you put in, right? And that's like the whole part of automation, right? Is if you have the information on how the product gets built and what parameters, like, and the logic behind how the parameters are linked to each other and how they affect each other when they change. Ultimately, that's what automation is all about, is to speed up that process so that you could just do it and not actually do it.
Yeah, well, and that's That's exactly what the built-in iLogic forms do. If you build a form inside of an assembly or a part and you put controls for the parameters and properties in there, you're directly modifying. If the user launches that form inside of a part or an assembly and types in a value for a parameter, you're directly modifying it. That's what the iLogic forms, that's how they work. So if that's what you need, definitely look into setting up how the built-in iLogic form functionality works. And we've done AVAs on that recently.
Yep.
Back and take, in fact, I did one on that. It was last year, I think.
Yeah. I mean, it's the beginning of the year, so it's not that long ago, Cameron.
Yeah. So yeah, go check that out. I mean, like I said at the beginning, iLogic forms are powerful, and you can do a lot of stuff with those. It's only if you, and that what I would say would be the starting point. If you need some user input, start with an iLogic form. See if you can do what you need to do with that. But when you get to the point where you need something a little bit more, that's when you start looking at building these external forms.
Yep, makes a lot of sense. And then we've got a great question from Michael that came from YouTube, and he's asking if it's possible to create web-based models from a simplified model. And then he says he'd like to bring up a simplified Inventor model to a web-based front end, drive the model through a question and answer form, and make it like an interactive viewer. So absolutely, that's something that a lot of people do from like the quoting end to be able to make their quoting more powerful, right? Is if a customer comes in and says, hey, I want to look at your custom furniture, for example, I'm going to input the dimensions that I want based on like, it's like, we'll use the same analogy that I use all the time is you go to like an automotive manufacturer's website and you like build your car, right? You pick the color, you pick all the options, and then it shows you a preview of what that looks like. It's essentially the same concept can be done with CAD models. Is if a user on a web-based front end can go ahead and input the parameters that they want for their product, whether that be furniture, cars, pumps, whatever, you could have that connect to an Inventor model that's updating and giving that person a preview. So that's definitely very possible. Let us know if that's something you're interested in. It's stuff that we've worked on for other people in the past. I think that's it for questions right now. Don't want to go over the hour mark, but Cam, I'd like to thank you for joining us this morning. I guess it's almost afternoon for you, and putting the session on for us.
Yeah, absolutely. Great to be here.
Absolutely. Thanks everybody for joining us. If we didn't get to your question, it's likely because it's kind of super specific to something maybe you're doing specifically, but reach out to any of us here at the KETIV team, whether that be your account representative or the marketing team who sends you these emails to remind you of these webinars. And if you want to have a deeper conversation about, what you're going through or what your plans are, let us know. We're more than happy to field those. So thanks everybody for joining today. Cam, you have a great rest of your day.
All right. Thanks.
Cool. Take it easy, everybody. Bye-bye.